Hello, this is question 12 from the step 2 paper from 2023. So the final question in the paper, which means we've got stats again. Each of the independent random variables x1, x2 through to xn has the probability density function f of x is a half sine x for x being between 0 and pi inclusive, and it's 0 otherwise. Right, let y be the random variable whose value is the maximum of the values of x1 through to xn. Right. Explain why the probability that y is less than or equal to t is equal to the probability that x1 is less than or equal to t raised to the power of n. Hence, or otherwise, find the probability density function of y. Okay, so we've got a whole load of these things here, all these x's, and we're picking the maximum one. But all of these x's are identical. I mean, they're independent of each other. They're all going off the same probability density function. So we could start off with that then, because that must be getting at to why we're doing this to the power of n. All these things are the same. We can just look at x1 and say, well, yeah, x1 is the same as x2, so on and so on. So let's say then the probability that x1 is less than or equal to t is equal to the probability that x2 is less than or equal to t, and so on for all xi, because they are independent variables with the same probability density function. So that's a good thing to start off with. Then we can have that so we want to get to the probability that y is less than or equal to t. So the probability that y is less than or equal to t. Now y is taking the maximum value out of all of the x's. So that's going to be the probability that x, well, let's say xi is less than or equal to t for all I is equal to 1, 2, ... up to n. Okay, and that is equal to the probability that x1 is less than or equal to t multiplied by the probability that x2 is less than or equal to t, all the way up to the probability that xn is less than or equal to t. Right, so we're there, aren't we? Because off of the bit that I've said at the top here, all of these things are the same. So I can say that is the probability that x1 is less than or equal to t, all raised to the power of n. Okay, enter otherwise, find the probability density function of y. Right, so that means then, well, these probabilities, this probability here, that x1 is less than or equal to t is going to be integrating the probability density function from 0 up to t. And that's what the probability density function gives us. So that is going to be, so I've got to remember to keep that power of n on the outside. So the integral from 0 to t, I've just taken the half from the half sine x onto the outside of the integral. So that gives me that probability that x1 is less than or equal to t. And then I need to raise that to the power of n. So let's integrate this thing then. So I'm going to, well, let's put I'm going to have double square brackets on this, one for the integral and one for not. Oh well. So a half, this thing is then going to be, so I'm going to integrate that to minus cos x, do that between 0 and t, and then raise all of that to the power of n. So I've got 1 over 2 to the n, that's separate from the rest of it. This is going to be a minus cos t, and then a plus 1, because we'll have a double minus. So that's going to be a 1 minus cos t, all to the power of n. So that's the probability that y is less than or equal to t, which I think is what they want. Oh no, they didn't want that. They wanted the probability density function. Oh right, okay. So I'm going to have to differentiate this to get back down to the probability density function. Yeah, we just integrated one probability density function to get to the probability, and now we need to get back to the other probability density function, so we have to differentiate again. So the probability density function of y, the thing that we want, is going to be this thing differentiated with respect to t. So I'm going to have an n from the bracket. That's going to then, the minus cos t will give me a sine t. Then I'm going to divide by the 2 to the n, and then I'll have a 1 minus cos t to the n minus 1. Okay, happy days. Let m of n be the median of y and mu of n be the mean of y. Find an expression for m of n, the median, in terms of n. How does m of n change as n increases? Right, so I'm going to need a new sheet for this. And I'm going to need this thing, aren't I? If I'm going to be looking at medians, because that's going to be equal to a half. Because it's going to be, yeah, this is our probability y is less than or equal to t, right? So I'm going to need this 1 over 2 to the n, 1 minus cos t to the n. Right, let's get that on the new sheet. So 1 over 2 to the n, 1 minus cos t to the n. So that's the probability that y is less than or equal to t. So for the median then, that is going to be equal to a half. So for the median, we've got 1 over 2 to the n, 1 minus cos t all to the n is equal to a half. So let's do 1 minus cos t. So I'll take the 2 to the n, I'll multiply through by that, and then I'll take the nth root. So I'll have 2 over 2 to the 1 over n. So that means, oh no, it's not cos t, it's m of n. Yeah, okay, I've got a little bit carried away there, just copying out this one, because we're looking at the median. This is the thing that I wanted, m of n. I've only just noticed that because I was about to rearrange to get m of n, and it's not in an equation that I've written out. So yeah, that's m of n. So now I'm going to have that m of n is going to be, well, it's going to be an inverse cos of 1 minus 2 over 2 to the 1 over n. Okay, that's fairly ugly. How does m of n change as n increases? Right, I don't like this second term that I've got in here. So let's rewrite that a bit more, in a bit more friendly fashion. So that's going to be 1 minus 1 over n. So n minus 1 over n. n minus 1 over n. That's just a bit easier to see what's going on in terms of the power on 2 there. So, right, so what do we want? How does that change as n increases? Well, what would we expect to happen here? We would expect, like, if you had started with, well, n equal to 1, so we just had one independent random variable out of all of these x's up here, then you'd expect y to come out at being pi over 2. You'd expect it to be in the middle. I mean, this probability density function is symmetrical here. So that's what we'd expect for n is 1. And that comes out when we've got, so if n was 1, we would have cos of minus 1, that would end up being 1 minus 1 is 0, gives us a pi by 2. Yeah, so let's go off of this. I mean, that makes sense straight off. But then as you put more and more of these x's in, as n increases, you'd expect the median to go up because we're more likely to get a higher value. And if n hits infinity, then we should be tending towards getting pi as the answer. So that's what we're going to expect coming out of this. It's a good way to verify that this result here is actually correct. So, okay, so when n equals 1, m of 1 is equal to cos to the minus 1 of 1 minus 1, which equals pi over 2. So that's what we'd expect. As n increases, m of n increases until, as n approaches infinity, we will get m of n will approach pi, because we're getting, this is going to be cos to the minus 1 of 1 minus 2, which equals cos to the minus 1 of minus 1, which equals pi. So that is what we'd expect just from looking at the setup of the question, and it's reflected in the equation here. So I'm pretty confident that this thing is right here, this expression here for m of n, because it's describing the behavior exactly as we'd expect from the setup of the question. Right, so that's part 2 done as well. Although I haven't done that much work so far in this question, so I think it's all going to be loaded into part 3. Let's get a new sheet up for that. Right, perhaps unsurprisingly, they now want us to work out the mean. So that's going to require, well, you can see in the answer it requires some integration. It's just the standard result, isn't it? So mu of n, that's going to be the integral. We need to integrate our probability density function multiplied by x. So that's going to be the integral from 0 to pi of x, and then our probability density function that we worked out in part I. So what was that? It was n sine x over 2 to the n, 1 minus cos x all to the n. So we're going to have to do this in parts. And actually, that's nicely set up for parts, isn't it? Because we've already differentiated most of this without the x. So u and u dash, we make that x and 1. Our v dash can be the n sine x 1, well actually the n I can just leave out. Sine x 1 minus cos x to the n, which means that the v is, oh actually no, I do need the n because the n's coming from the power, isn't it? I was thinking I'll just take that out as another constant, so let's leave that n back in again. So I've got that, oh no, that wasn't n, that was n minus 1. Yes, because we differentiated it. So that will end up being 1 minus cos x all to the n. So let's whap all of this into actually working out this integral. So mu n is going to be, so I want my u and my v. So I've got an x, 1 minus cos x all to the n. I've still got that 2 to the n kicking around. And then that's between 0 and pi. And then I need to take off my v du. So from 0 to pi, which is 1 minus cos x all to the n. I've still got the 1 over 2 to the n dx. Okay, is that looking anything like, yeah, I mean that is the integral that I've got in the second part of what they want as the answer. So I just need to evaluate this first term on the right hand side. So that is going to be pi times, well, 1 minus minus 1, so 2 to the n divided by 2 to the n. So yeah, it comes out exactly what we want. Pi and then 1 over 2 to the n, integral from 0 to pi, 1 minus cos x to the n dx. Okay, so that bit wasn't so bad. Now in A, we need to show that mu n increases with n. So that means mu n increases with n. So we need the integral to be decreasing. And then we'd have that mu n is increasing. Okay, because yeah, it's not going to be going above, well, I say decreasing. Are we going to be able to get that to be negative on this? What are we doing? So as we increases with n, so when n is 1, then this thing inside the integral, yeah, this is all going to be positive. All right, okay, so let's put some of this down. So when n equals 1, mu of n, well, mu 1, let's undo that, put a 1 in there, I'm crossing everything out. Mu of 1 equals pi minus something positive. So therefore, for, well, let's say mu n will increase if the integral decreases. Okay, so that's the thing that we want to show on all of this. So how are we going to go about doing that? Well, what have we got here? 1 minus cos x all to the n. So that is, and then we're dividing it by 2 to the n. Just trying to think. So we want this thing to be getting smaller and smaller as n increases. So 1 minus cos x to the n, that's going between 0 and 2. So the most that we can get out of 1 minus cos x to the n is 2 to the n. Yeah, so that's fit because we're dividing it then by 2 to the n. Yeah, so that's going to work, isn't it? Yeah, so right, let's write out something like that. So 1 minus cos x is less than or equal to 2. And we've then got, so we can say that 1 minus cos x divided by 2 all to the power n. That's just a nicer way to write it, I think, to make this point clear. That will tend to 0 as n tends to infinity. Yeah, so that works. So what am I trying to say here? Show that mu n increases with n. So therefore, as n increases, the 1 over 2 to the n integral from 0 to pi 1 minus cos x to the n dx decreases. Therefore, mu of n will increase. Wow, okay. Right, so that's another sheet filled up. We're on to the last part anyway, just on part B now. Show that mu of 2 is less than m of 2. Well, we can work these things out to some extent, can't we? I mean, we can do, let's start off by doing mu of 2. So mu of 2, so that is pi minus 1 over 4 integral to 0 to pi of 1 minus cos x squared dx. Okay, so could probably do that integral, and I probably want to square out the bracket. It's probably going to be easier, isn't it? And then I'll have a cos squared that I can just change into a cos 2x and go off of that. So yeah, let's give this a bash then. So I've got a pi, still got the quarter. So 0 to pi, let's just do the square first. So 1 minus 2 cos x plus cos squared x dx. So that's going to be, I'm going to fit it on again on that line, pi minus a quarter integral 0 to pi 1 minus 2 cos x. So cos squared x is, let's go, I always have to write these things out. Let's take a little bit of screen over here. So cos 2x is cos squared minus sine squared. So that's 2 cos squared minus 1. So cos squared x is going to be a half of 1 plus cos 2x. Right, so that's a half of 1 plus cos 2x dx. Right, so now we're on to something that I can actually integrate here and do. So I've still got minus a quarter, then square bracket it. So that's going to be an x. That's going to be a minus 2 sine x. And then I'm going to have an x over 2. And then I'm going to have a quarter of sine 2x. Okay, from 0 to pi, which is equal to pi minus a quarter. And then I'm going to have, well, a pi. Then I've got a 0. I've got a pi by 2. I'll make that look like a pi. Then I've got another 0. Then I'm going to have a 0, a 0, 0, 0. So all of those disappear. So I've got a, what's that? 3 over 2, 3 over 8, 1 minus 3 over 8, 5 pi over 8. Okay, so at least I've got what mu 2 is. So now I need to get m. So what did I have for m? That was in part 2. That was a while ago, wasn't it? Part 2. Where's part 2? M, so inverse cos 1 minus 2 to the n minus 1 over n. Okay. So m of n inverse cos 1 minus 2 to the n minus 1 over n. Okay, so that means that m of 2 is equal to cos minus 1 of 1 minus, so that's 2 root 2. Okay. Right, but that's got an inverse cos, and that one doesn't. I can't do inverse cos of 1 minus root 2. I can't do a cos of 5 pi by 8. I was just wondering if I could cos my mu 2 and then do a cos of both of them and then compare those, because I can't do that either. So I can do cos of 5 pi by 4. I know how to work that out. So can I make that a double angle? Can I make that a double angle? Maybe. So that could work. I mean, I've just had this thing, haven't I? So yeah, maybe try doing that if I double angle it. Okay, so cos, let's try this, because I've got here that cos of m2 is equal to 1 minus root 2. So that's one thing that I can look at. So I've got to change one side or the other. I just don't see I can do anything with this in order to get a sensible answer. So I think I'm going to have to mess around with mu2. So let's say then that I've got cos of 5 pi over 4. Let's go with that. So that's going to be, God, let's try and think about this. So I've just gone, I'm going to be on negative. That's going to be minus root 2 over 2. Okay. And that is going to be equal to, well, I'm using this identity here, aren't I? So 2 lots of cos squared 5 pi over 8 minus 1, okay, is equal to this thing, right? So, and that is my mu2. So I've got the cos squared of mu2 is going to be equal to, well, 1 minus root 2 over 2, all multiplied by a half. Okay. So it's still, I don't know, it's got some similarities because I've got 1 minus root 2 sort of lurking around in some of these things. Let's write that as a quarter of 2 minus root 2. Okay, so can I compare, what can I say about these things? I mean, that's negative, and what do I know about mu2? Mu2. I mean, the cos of that is negative. Cos of 5 pi over 8, that would be negative as well. So what's that telling me? Cos of mu2 is negative. Yeah, so I want to have the negative square root of this thing if I was going to do it. So this is negative. Let's just try and keep this in mind as to what's actually happening here. Yeah, cos of mu2, let's write that down as well. Cos of mu2 is negative, so they're both negative things. I'm not sure I want to square root this. Doesn't look like much fun. I mean, they're sort of comparable. They're almost, it's just like, do I want to square root this or do I want to square that? It's probably going to be better to square, isn't it? Because otherwise I've got a nested square root. So let's say cos squared of m2 is then going to be, well, I'm going to have a 1 plus a 2, so I'm going to have a 3 minus 2 root 2. Okay, so I've got that, and then I've got cos squared of mu2 is equal to that thing. So now what do I want to do? Now I want to say which one of these is bigger. I need to show that this thing is smaller. This one's meant to be the smaller one. So if I, well, let's look at the difference between them and see if I end up getting something that's positive or negative. So let's do cos squared m2 minus cos squared mu2. Okay, so that is 3 minus 2 root 2, and then I need to take off all of this thing. So that's going to be taking off a half, and then I need to take off root 2 over 4. Okay, so that's giving me 2.5, and then it's giving me 1 3/4 lots of root 2. 1 3/4 lots of root 2. Right, so is that going to be positive or negative is what we're getting at. If that's greater than 0, then it's not so bad. Right, let's write these out in proper fractions or something like that. So let's compare. Well, essentially what I'm saying is which is bigger. Let's multiply them both by, say, 4, shall we? And then see what we're actually going to get. So 4 lots of 2.5 is 10. And then 4 lots of this thing is 7 root 2. That's what I need to decide. Right, so then which way round do I want to look at this? Which way round? 7 root 2 is, I mean, that's going to be 7. I mean, that's going to be smaller, isn't it? That is going to be smaller. 7 root 2 is going to be smaller than 10 because I know what root 2 is. Are we allowed to use that, do you think? I mean, it's definitely come up with the answer. So yeah, I've got that this thing is going to be, let's put that there, that is greater than 0. Therefore, I'm saying that mu2 is less than m2. But I just need to prove from this thing. So I'm saying that 10 is greater than 7 root 2 is what I'm saying. So I want to do that because, which way round shall I put that? Well, if I do that 7 over 10 is less than 1 over root 2, so root 2 over 2. Yeah, so that'll work. So i.e., this is getting a bit of a mess now, root 2 is greater than, let's undo that bit, root 2 is greater than 14 over 10, which we know it is. And I can justify that by saying that 14 squared is 196, which is less than 200. Therefore, root 2 is, well, greater than 14 over 10. Right, okay, so there must be a slightly better way of doing that. Let's just run through, because I think I was kind of stumbling my way to the end of all of that. So I was trying to show this, that mu2 is less than m2. So I worked out mu2 first. So that was going through all of the actual integration based on the formula that we just worked out, and got that mu2 is equal to this. So I got that was 5 pi over 8. Then I went back to part 2 to see what we had for m2. But m2 was an inverse cos. But still, this is what m2 is over here. So didn't think there was much I could do with that because there's no way I'm going to work out inverse cos of 1 minus root 2. So I've cosed it and said that cos m2 is that, and then started looking at cos of mu2 and then compare these coses. So this is why I was looking at them both being negative, because if they're both negative, cos m of 2 and cos mu of 2, then yeah, we can compare them looking at the magnitudes, and we don't have to worry about whether when squaring them we're going to end up messing up the inequality, because that's always the worry when you start squaring things which have got different signs. So so I've got cos of m2, and then I want cos of mu2. Now I can only get cos of mu2 by working through a double angle, because I don't know how to do cos of 5 pi over 8, but I do know how to do cos of 5 pi over 4. So this then gives us a cos squared from the double angle formula, which means I've got a cos squared mu2. I can then do a cos squared m2, and because they're both negative, it's not going to mess up the inequality. Then compare those two cos squareds to see which one of them is bigger, guided by the answer in the question. So by putting the larger one first and then seeing, is this thing positive? So is this thing here, 2.5 minus 1 3/4 lots of root 2, is that positive? Which essentially comes down to which is bigger, 10 or 7 root 2. Looking at what's really handy with the 14 squared business being less than 200, that's a good way of showing that 14 over 10 is less than root 2. So it's a way of justifying that without having to go to a calculator or just a statement of, well, I know that root 2 is greater than 1.4. But you might be able to get away with that anyway. It's not like it's a great leap into the dark in order to say that root 2 is greater than 1.4. Right, okay, that got really fiddly towards the end. I mean, there might have been a smoother way of doing it, or if I'd thought about, you know, if I'd seen this before, maybe I'd be able to go through, you know, on a second run through of this, I might have a smoother way of doing part 3b. But part 1 was pretty straightforward. Part 2 wasn't that bad either. I doubt there was much going on there. Part 3 was more of an exercise in calculus than it was in stats, really, particularly for the first part. And then, yeah, 3A was fine, and 3B was quite fiddly. So, yeah, I'd say it was still a fairly tough question, but I think overall, it was for me, it was certainly easier than question 11. It wasn't trivial, but yeah, it was better than question 11. But there you go. That's step 2 for 2023 wrapped up.